they gave us a picture, and on the picture, they kind of marked locations along the ramp. This one, you can't see it, but there's a location marked right here at the beginning. It's just not labeled. If you go to the next page, I think that we can probably assume that this is supposed to be 0. I think 0 represents the origin. So for all of these, assume that's where the motion sensor would be. That's the origin of your graph. And pay attention to this too, because people did not in the last class period. The arrow indicates the direction of motion, I believe. But it tells you quite clearly what the velocity is at time 0. That's what that little 0 next to the V means. Velocity at time 0, do this one. And I'm going to ask everybody in the room to do the same thing. I'd like everybody to just take a moment and sketch the position versus time graph. And then flip your board over so your neighbor doesn't get your benefits. I'll let you help your neighbor later, but right now, it's going to be who can do it and who can't. All right, 60 seconds is going on. Okay. Now look, I don't know what the problem is. I mean, really, I don't. I think in many ways you are refusing to do something I've suggested. So I'm going to just say a couple words, a few sentences. You look at yours. Don't look at your friends. You don't need their help. You need to do this on your own tomorrow. You understand, I'll have more than one tomorrow, so you will not have the one next to you. So I'm not even going to look at people to see who's erasing. I'm going to kind of close my eyes and just state things. At time 0, where should the dot be? I don't want to hear anything. I'm helping people fix theirs. So at time 0, where should the dot be? At time 0, should the slope through that dot be positive, negative, or 0? At time 0 is the velocity of the object positive, negative, or 0? At some time in the future, is the dot close to the origin or far away from the origin? At some time in the future, should the slope through that dot be positive, negative, or 0? At some time in the future, is the object's velocity positive, negative, or 0? Is there a way to connect these two dots together smoothly, connecting their slopes? Is there a way to connect these two dots together smoothly, connecting their slopes? Now, I carefully looked down the whole time I was doing that, because that's the process you should be using, I think, especially if you have no idea what to do. I do think that there's a large number of you who believe you can just memorize what it should look like. That's not serving you clearly. So I'm going to walk the room again and see if what you've done has changed. Is to convince the others that their right answer is the wrong answer. There are more people with the wrong answer now than the last time I came through. I know. At time 0, the object appears to be at the origin. That's what I see. So on my position graph, I will put a dot at the origin. Time 0, dot. At that moment, everything's good. At time 0, the object's velocity is 0. So at time 0, the object's velocity is 0. At time 0, therefore, the slope should be 0. The slope of the position versus time graph is the velocity. If the velocity is 0, and I saw many heads do this, then the slope must also be 0 for the velocity graph, for the position graph. At some time in the future, is the object going to be close to or far away from the origin? I believe at some time in the future, the object will be 50 units away from the origin. I don't need to label it with 50. I'm just being way out in front of you right there, just to make sure you understand. That's what I see. I'm kind of thinking that, and I'm thinking maybe, okay, sometime it's going to be there. It's going down a ramp. There are 7 ramps in the room where this could be demonstrated at any moment. I didn't see anybody roll a car down one, but you have already. I'm pretty sure if started at the top, it'll be traveling faster at the bottom. That seems very reasonable to me. So I think the velocity will be greater at the bottom than it is at the top. If the velocity is greater, then the slope will have to be steeper. Now I have to decide whether that slope is steep in the positive direction or steep in the negative direction. I believe it's traveling away from the origin. That makes it steep in the positive direction. So now I want to ask myself, is there a way for me to connect these 2 dots together in a smooth way that connects their slopes? I believe there is. I'm going to ask with some fear and some trepidation for you to perhaps erase your whiteboard and now craft the appropriate velocity versus time graph. And while we're doing that, how about the acceleration versus time graph? There is a piece of knowledge you need to create the acceleration time graph. I've said it in class on multiple times, but I'm going to say it one final time. Well, final time for today. Acceleration is the slope of the velocity graph. And we are studying objects with a constant acceleration. Okay. 60 seconds, make a velocity and an acceleration graph and flip it over. Here. So everybody in the classroom that I saw had a velocity graph that looked like this. Good. I'm glad. That's kind of what I expect. The velocity started from rest. It went to some positive location, straight line connecting them. Almost everybody had the acceleration graph correct too. All but a handful. The acceleration is the slope of this graph. This is a straight line. So wouldn't the slope be a constant? It's the same as the slope here, the same as the slope here. Are those the same slope? So the acceleration graph has to be the same at those 2 places, which means the same number. So this is going to be the acceleration graph, just something in the positive. It doesn't really matter where, just indicate that it's positive. The slope is positive, the acceleration is constant and positive. Which brings me to question E, F, and G. Mathematical expressions. We have just a couple that you have to worry about here. When I say mathematical expressions, we're talking about whether it's quadratic, linear, or constant. All I'd like you to do is say proportional to, that's what that symbol is, proportional to. And t squared, or t, or constant. And I'd like you to go one step further. You can tell me whether the proportionality is positive or negative. If it's concave down and it's quadratic, it'd be a negative t squared. If the line has a negative slope, it would be a negative t. And if that slope is negative, it would be a negative constant. So you can put a negative in front of those. So in the case of these, I'm not going to leave it a mystery. The first one is a quadratic. I'd put x is proportional to t squared. The second one is linear, and it's got a positive slope, so I would put v is proportional to t. These are not a surprise. They're on the board in front of you. If you get these wrong, you're trying hard to get them wrong. V is proportional to t, x is proportional to t squared. It's right there. It's just whether it's a positive proportionality or a negative proportionality that you should really be considering. And in all cases, we are studying uniform accelerated motion. This has to be a constant for that to be true. It's just whether it's a positive constant or a negative constant that matters. There is something else, though, I do want to do, and that's question D. I want to do the motion maps. And you don't know what a motion map is, and so I'll explain it. It's very easy. There are 3 places indicated on the track, which means that at some point or another, the ball is at these 3 places. The first thing a motion map shows is where the object is at different points in time. It will be at these 3 places at different points in time. The next thing the motion map, it has arrows that indicate the size and direction of velocity and acceleration. So I'm going to draw an arrow for velocity. At time 0, I draw no arrow. Its velocity is 0. After some time, it's made it to the 25 mark. It's got a little bit of velocity, and I'm pretty sure it's in that direction. I'll label it V. Now, at the 50 mark, is the velocity greater or less, or in the other direction? Greater, and in the same direction. Longer arrow. A motion map just kind of tells us what we think is happening for each of the 3 measurements: position, velocity, and acceleration. Now, in all 3 of these cases, the object is on the ramp. It is accelerating. The acceleration was a constant. So when it was released, it accelerated this way. It had to have an acceleration at time 0, or else it never would have left the start. Nothing would have changed its velocity. And if the angle of the ramp didn't change, then the acceleration is the same here. Same size arrow pointed in the same direction. Though, it's the same ramp, just tilted the other way. So there's an implied 0. And it's explicit on some pictures and not explicit on others. So 0. We're going to just, after some time has gone by, is the object close to or far away from the origin? After some time has gone by, does the object have a positive, negative, or 0 velocity? A little more hesitant there. Is it traveling towards the origin, away from the origin, or not traveling? That's negative velocity. So should the object have a positive or a negative slope? Is there a way to smoothly connect these 2 dots together, including their slopes? Not terrible. Good job. Thank you. And no, I could not tell you whether you were right or wrong ahead of time. Could you tell me how to do these next 2? I don't have my glasses on, but I think the bottom one looks like this. The velocity graph, is that what you have drawn there? And the acceleration graph I can't see. Does it look like that? All right, so that's what is on hers. I think you guys can see it better than I. Fluorescent orange marker. At time 0, is the object's velocity positive, negative, or 0? After some time has passed, Is the object moving towards the origin or away from the origin or not moving? Is that a positive or a negative velocity? Now, how you connect these is related to the thing we're studying right now. It should be a straight line. We're studying uniform accelerated motion. The slope of this line is supposed to be a constant. It should be a straight line. But you can ask yourself something else. Was the track constantly inclined? Meaning, was it the same angle the whole time? If it is, then this line's got to be a straight line. And more than that, it should be a ruled line, like with a ruler. The next graph is a graph of the slope of this line. That's it. Good job. All right, one more thing, I guess. We got to do the motion map. I want to see that. So let's see who's going to help us there. Can I assume you drew 3 dots? Which dot do you want to start with? Okay, you have a picture drawn. Let's just look at your picture. I have my glasses so I can see. I only brought my sunglasses, so. Okay, I'm seeing what I want to see. How many of you would agree that her image is correct? I like it. I think it's okay. In fact, I'd go so far as to say she did a great job. Does the velocity become a bigger arrow or a smaller arrow over time? To the left or to the right? Okay, so I think that the whole time. And the acceleration, should that be an arrow drawn to the left or to the right? Should the arrow change size or stay the same? Stay the same. Do all 3 dots get the arrow? Yes. Yes. All right. So there's only 2 minutes left. So be cognizant of when they tell you it's not 0. Okay? Because that's going to come up. So we did not have a chance to do this as a group. You should be able to do it in 2 minutes. But I'm going to be very clear. Anything on this worksheet's fair game tomorrow. And anything on the worksheet you did already is fair game. So try this one quick. I'd focus on the graphs if I were you. I won't have time to call you out. But if you can practice, that would be great. Ask your questions. Where is the object at time 0? How fast is it going at time 0? Positive, negative, or 0? Ask those questions. I'm done talking. I'll show you. So, first one. Second one. Last one. Oops. Trying. Maybe I can't get the last one. There. Second one. And last one. Starts fast, slows down. Velocity starts positive, goes towards 0. If you continued it and did a full parabola, that's fine. I only did it to the top of the ramp.
Like you said, so would it be okay for full parabola? So it would be fine, right? Okay. And so for the velocity, you